Good morning, students. We'll continue our topic, beta. The concept of equilibrium. As we have done yesterday, that chemical equilibrium occurs when a reaction and its reverse reaction proceed at the same rate. Here, reaction and reverse reaction means the forward reaction as well as the backward reaction. Because as we know that equilibrium occurs in a reversible reaction, right? So when the rate of forward reaction becomes equal to the rate of backward reaction, the chemical equilibrium established. See, as a system approaches equilibrium, both the forward and the reverse reaction or backward reaction are occurring. At equilibrium, the forward and the backward reaction are proceeding at the same rate. As you can see in this graph, that the rate of forward reaction and the rate of backward reaction when becomes equal, it means the number of reactants taking part in the reaction will become equal to the number of product formed. It means that system is in equilibrium. Once the equilibrium is achieved, the amount of each reactant and the products remain constant. Here, you can see the example of NO2 and N2O4 has reached the equilibrium. Now, students, law of mass action. So, according to law of mass action, it is a relationship between the rate of reaction and the concentration of reacting substance. And this relationship is known as law of mass action. Now, it states that the rate of chemical reaction is directly proportional to the product of molar concentration to the reactant, molar concentration of the reactant at constant temperature at any given time. It means, students, suppose one example is there. Consider a generalized reaction, students. See, here A plus B gives you C plus D. Here A, B, C and D. Here A and B, capital A and capital B represents you the reactants and capital C and capital D represents you the products. But the small a and small b are the coefficients along with small c and small d. We know that. Suppose we have one simple reaction between species A and B. A plus B gives you product. So according to law of mass action, what it indicates that rate of reaction, which is given by small r, students, that is directly proportional to the molar concentration of reactants, right? So if A plus B gives you product, according to rate of reaction, rate means speed. Speed किस पे depend कर रही है? Only the molar concentration of reactants पे. So molar concentration, concentration can be shown with the help of square bracket, students, right? So A and B are the molar concentration and K, when proportionality sign को जब हम हटाएंगे तो आपके पास rate of reaction किसके बराबर होगा? K, A की concentration and B की concentration, students, right? And A and B are the molar concentration. Like I have shown downstairs, here I have taken three reactants, A plus B plus C gives you product. And according to law of mass action, it may be written as R is equal to K, A की concentration, B की concentration and C की concentration. But here coefficients are also given, students. So coefficient जो है वो power में जाएगी, right? So according to the law of mass action, the rate of chemical reaction is proportional to, जो इसका बेटे हमारे पास यहाँ पे रिलेशन है वही इसकी डेफिनेशन है, वही इसकी स्टेटमेंट है. वो क्या है? The rate of chemical reaction is directly proportional to the product of molar concentration of reactant with each concentration term raised to the power equal to the number of molecules of the respective reactants taking part in the molecule. So here in this equation which is shown here, I can show you with the help of arrow, right? See here, this small a, small b and small c, these are the coefficients. So when we represent our rate of reaction, it will equal to the, it is directly proportional to A ki concentration, B concentration and C concentration and raised to the power of their coefficients. Here just see how we'll represent the लॉ ऑफ मास एक्शन के अकॉर्डिंग हम रेट ऑफ रिएक्शन को कैसे लिखेंगे, राइट? Now the next is law of chemical equilibrium and the equilibrium constant, student. This is very important again. Now suppose law of mass action may be applied to the reversible reaction to derive the mathematical expression for the equilibrium constant known as law of chemical equilibrium. So consider an equation a plus b reversible sine c plus d gives you c plus d, and small a, small b, small c and small d, they are the coefficients, students. So suppose take one example. Here reactant I have taken N2O4 and product is NO2. So according to law of mass action, if I want to write down the rate of forward reaction is equal to or directly proportional to the concentration of N2O4. So after removing the proportionality sign, rate will be equal to Kf. Here F stands for the forward reaction. किसकी कंसेंट्रेशन पे डिपेंड कर रहा है बेटे रेट फॉरवर्ड रिएक्शन का? रिएक्टेंट की कंसेंट्रेशन पे, दैट इज N2O4. And second is, if I talk about the reverse reaction or a backward reaction, the backward reaction will be NO2 gives you N2O4. The rate law, according to this, the rate of backward reaction or rate of reverse reaction will be again directly proportional to the reactant. Here now NO2 is a reactant, and here before NO2, the 2 is a coefficient, it will goes to the power. So we can represent the rate is equal to Kr, R means reverse reaction, or you can use B also for the backward reaction, will be directly proportional. Kiske hai bete? NO2 ki concentration raised to power 2, right? So when the equilibrium attained, right, the rate of forward reaction will become equal to the rate of backward reaction, which can be represented like this. And rewriting this equation, the rate of forward reaction upon the rate of backward reaction will be this. Now the ratio of the rate constant is the constant at the temperature, and the expression can be used as this. हम rate of forward reaction जो हमारा के एफ और के बी की जगह हम एक और नया कांस्टेंट लेंगे जिसको हम के ई क्यू कहेंगे, विच इज नोन एज equilibrium constant and has a constant value for a reaction at a given temperature. And the above equation is known as law of chemical equilibrium. Now we can write like this also. Suppose we have one reversible reaction. So we can write, suppose Kc. Kc here stands for equilibrium constant and C means concentration. We can represent like this also. So what is the statement of this law? At a given temperature, the product of concentration of products raised to the respective stoichiometric coefficient in a balanced chemical equation divided by the product of the concentration of reactants raised to their individual stoichiometric coefficient has a constant value, which is known as the law of chemical equilibrium. Thank you very much.